Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. Let us continue solving KSET 2025 Physical Science question paper. In this video, I am going to cover 4 more questions. The first question in this video is for a transistor circuit. They have given the transistor circuit here. Can you see? Find out VCE when V in which is equal to 0 volt. They have given. Right, we need to find VCE. What is the value for VC? That is voltage across collector and the emitter we must find. That is this point. Now, how to approach this question is, here IB current will be flowing, right? A current through a base, right? And here IC current will be flowing right to this point, and here it is open. So usually IE current will flow, but here no need to write. Now they have clearly mentioned that V in which is equal to 0 volt. Let us consider this to be a first loop. Apply KVL to this first loop. On applying KVL to this first loop, what will happen? It will be minus V input plus RB into IB plus VBE which is equal to 0. What is this VBE means? Base emitter voltage. It will be around, for silicon it will be 0.7, for germanium it will be 0.3, or else you can omit this. Now on rearranging, I'm omitting this. On rearranging, I'll get V input which is equal to RB into IB, right? Now they have given already V input which is equal to 0 volt. Now what will be the value for uh, IB? The value for IB which is equal to 0 ampere. From this loop, I got the value for IB which is equal to 0 ampere. Why I am doing this means, we have a relation between the IC and IB that we know, right? IC or IB is directly proportional to IC, right? Now, or else we have the formula that is IC divided by IB which is equal to beta. Everyone will be knowing, if the IB value which is equal to 0, obviously IC value which is equal to 0, right? It will be 0 ampere. Now what is our task is, we must find the value of VC. Just apply KVL to this loop 2. Okay, the direction of the current is along the IC. The arrow mark it is showing along the IC only. So apply for this entire loop KVL. If I apply KVL for this loop 2, what I get? It will be minus VCC plus IC into RC plus VCE. VC which is equal to 0. On rearranging the terms, here IC which is equal to 0, it will be 0. Now VCE which is equal to VCC, right? Now what we get the answer, VCE which is equal to, they have given here VCC value, that is 10 volt plus 10 volts. So VCE will be also equal to 10 volts. So I hope this question is very clear to you people. Only main thing is, we must understand the IB, IC currents and the IE currents, where it is flowing. The main important basic concept is this KVL, that is a Kirchhoff's voltage law, that we must know. This concept we have studied from the previous classes only. I hope everyone is clear. Let us move on to the next question. This question is also from the electronics topic. A certain D MOSFET is biased at VGS which is equal to 0 volt. This is given. Its data sheet specifies IDSS which is equal to 20 milliampere and VGS, that is off, which is equal to minus 5 volt, the value of the drain current. So the value of the drain current for D MOSFET is calculated by the formula. I'll give the formula. Before that, what is this? VGS is a gate source voltage. So I'm going to write the given terms here. VGS, which is equal to 0 volt, and what they have given IDSS. What is this IDSS means? Drain source saturation current. Okay, so IDSS they have given to be equal to 20 milliampere. It is 10 to the power of minus 3 ampere. You can take like that also. You can keep like this also, because they have given the options in terms of milliamperes only, not in amperes. So now what they have given VGS off. What does this means? Means a gate source cutoff voltage. Okay, the value is minus 5 volts they have given. So what is the formula to find this drain current is found out by the formula, that is ID, which is equal to IDSS into 1 minus VGS divided by VGS off, that is cutoff voltage. Okay, whole square, this complete whole square. This is a formula to find. I am repeating again, that is IDSS into 1 minus VGS divided by VGS of whole square. Okay, now substitute everything. ID, which is equal to IDSS, that is 20 milliampere into 1 minus VGS, it is 0 volt, divided by VGS of, which is equal to minus 5 volt. 0 divided by anything will be equal to 0. So 1 square is again 1. Now the drain current value will be equal to 20 milliampere. Now 20 milliampere belongs to option 3. So option 3 is the right answer. Right? Now let us move on to the next question. The next question, which is related to the op-amp, that is operational amplifier. What they have given, let us read the question. The gain of the amplifier shown in the figure, the op-amp voltage gain of the op-amp is, that is 1 lakh, it is given. Now we must find the gain of the amplifier. This is also based on the direct formula only. So the gain of the amplifier. Now we must find which is, it is inverted or non-inverted. We must find that, no. Now this plus symbol in the op-amp, it is called as a non-inverting, and the minus symbol is called as a inverting, right? When V input is connected to the plus, we call it as a non-inverting amplifier. I hope everyone is clear. When V input is connected to the positive of the amplifier, we call it as a non-inverting amplifier. Okay, now for the non-inverting amplifier, to find the gain of the amplifier, we have a formula. That formula I am writing as AV, that is gain, which is equal to 1 plus RF divided by this R1. They have given the RF value which is equal to 100 kilo ohm, and they have given the R1 value which is equal to 4.7 kilo ohm. Directly applying this formula, you will get the answer. It will be 1 plus RF value is 100 kilo ohm divided by R1 value is 4.7 kilo ohm. Kilo ohm will get cancers. Remember one thing, the gain has no unit. Okay, it is 1 plus this value. Now to solve this value, so it will be 1 plus 100 divided by, if I remove the um, decimal point here, it will be 10 to the power of minus 1. If it goes upside, it will be 1000 divided by 47. Now 47 into 21, if I do this, I'll get around something 1 sevens are 7, 1 fours are 4, 7 twos are 14, and 7 twos are 8, 9. It will be 987. So somewhat it is nearly equal to 1000. I'm doing the approximation. Why? Because in the case set, they are not going to give any calculators to us. So it will be ones, it will be 21. Nearly I'm taking it as a 21. So 21 plus 1, it will be equal to 22. So which is the nearest value? I'm going with the option 3 is the nearest value. If I do with the calculator, you will get the accurate value, that is 22.3 will be the accurate value. So directly applying the formula for a gain of a non-inverting amplifier, you will get the right answer. Now let us move on to the next question. This is a very easy question. So these kind of a questions, if you attempt, it will save your time as well as it will fetch you marks. Okay, yes. In the given digital logic circuits, A and B form the input, the output Y. So they are asking the output Y. As you know, this is a OR gate and this is a AND gate. So here NOT is also connected. It will be an AND gate. Here it will be NOR gate. Okay. So I hope everyone is clear. Okay. Now this side it will be A bar, or you can call it as A dash also. It's fine. I'm calling it as, here it will be B. So the OR operation is present here. So it will be A bar plus B. The solution will be A bar plus B. Here B and here directly A. So OR operation again it will be A plus B. Now this is connected to the AND gate. So it will be A bar plus B into A plus B. Again we have one NOT gate, so it will be whole bar. So using the De Morgan's principle, I need to separate this. Separate this bar means the multiplying term will be given to the addition. So it will be A bar plus B whole bar plus A plus B whole bar, right? Now again I need to separate these two. If it is addition, it will be multiplication. So A bar bar into B plus A bar into B bar, right? Now bar bar get cancels. It will be A into B plus A bar into B bar, right? Now it will be now what I can do, I can take, it will be, I have missed here, it will be B bar. So I have missed here B bar. So it will be B bar again. That's what I'm thinking, what I missed. So come back here. According to the rule, we have De Morgan's rule, that is A bar plus B whole bar we have. We need to separate this terms means the multiply symbol will come in the middle. So here bar will persist again. So from here I can take B bar common. It will be A plus A bar. From the Boolean algebra I can take this to be 1. We have some of the rules for this. According to that rule, A plus A bar, which is the value which is equal to 1. So we got the answer to be B bar. So which is the correct option? Option 4 is the right option. Thank you for watching. For more videos, visit my channel, that is Physics Unwrapped.